In this video, we will study the most commonly used domestic water supply system for a high-rise building. We call it downfeed or indirect domestic water supply system. There are 5 major components of this system. Number 1, underground main water tank, where we store water for the building. Number 2, transfer pump, which supply water from underground water tank to the rooftop water tank. Number 3, rooftop water tank, which supply water to the building. Number 4, rooftop booster pump, which supply the required pressure to the higher floors. Number 5, PRV, which control the pressure for the floors or branches. Now we will do a sample calculation, where first we will calculate the daily water demand. Then we will calculate the rooftop water tank capacity. Then we will calculate transfer pump capacity. Then the size of underground water tank. Then we will select the terrace booster pump capacity, and we will study the PRV pressure settings. To calculate the daily water demand for the building, there are two methods. Number 1, fixture unit method, and number 2, per capita daily water demand methods. In our study, we will follow the fixture unit method, and we will use the International Plumbing Code data. To calculate the daily water demand for the building, we will use this Excel sheet. We have a building where we have 1500 WC with flush tank, 1500 lavatory that are private. We have shower 1000 that are also private, and 500 bathtub, and 200 kitchen sink that are also private. Here we use the water supply fixture unit value from the International Plumbing Code. So in this way we have calculated the total fixture unit 9400, and the water demand in GPM equal to 754.6 GPM. And this water demand is for peak hour. Assuming peak factor 1.8 and the duration for peak demand equal to 60 minutes, then the mean demand will be equal to peak demand divided by peak factor. Then we get the result for mean demand equal to 419.2 GPM. And the transfer pump capacity will be same as mean demand. So our transfer pump capacity will be 419.2 GPM, and we will use two pump, one running and one standby. And the minimum size for overhead water tank we calculate by the formula. Overhead water tank size equal to peak demand minus mean demand into duration for the peak demand. Peak demand we have calculated here 754.6 GPM, and the mean demand we already calculated 419.2 GPM, and the duration for the peak demand equal to 60 minutes. When we apply this value in the formula, we get the overhead water tank size 20,123 gallon, or in meter cubic it is 76.06 cubic meter. For underground main water tank size, generally we store water for 2 days. As our mean demand value is 419.2, so after calculation we get the underground water tank size 1,207,296 gallon, or 4,570 cubic meter. To calculate the pressure in riser, we will use this formula. To raise water to a height of 1 feet, we need a pressure of 0.433 psi. To calculate the terrace booster pump capacity and use of PRV in the water supply distribution system, we will study different cases. In case 1, we will study the most commonly used method for the hotel buildings. Generally for high-rise building, we set pressure for toilet from 1.5 bar to 2 bar if it is possible. As there are big number of sanitary fixtures inside the building, and our purpose to do it is only to save water. But you must remember one thing, While selecting the minimum pressure for the building, you must consider the minimum pressure required for the sanitary fixture that is available inside the building. However, as per International Plumbing Code, the maximum pressure limit for domestic water supply inside the building is 80 psi. It is the riser diagram for a 16-story hotel building. We have the main water tank at the basement, and there is a transfer pump at the basement which transfer water from the main water tank to the water tank at the roof. Then water is distributed to the building from the rooftop water tank. The minimum pressure requirement for all branches is 1.5 bar. If we supply water from the rooftop water tank to the whole building by gravity, then you can see the pressure for the top 5 floor will be less than 1.5 bar, which is the minimum requirement, and the pressure for the top floor will be 0. So to solve this problem, we will make a separate piping network for this 5 floor, and we will use a small booster pump with a pressure which is our minimum requirement, that is 1.5 bar. As per our design criteria, we need to keep the pressure for the branches between 1.5 to 2 bar. But after using the booster pump, the pressure for the last 2 floors among these top 5 floors becomes more than 2 bar. So we will use the PRV for these 2 floors, and we will set the pressure for these 2 floors 1.5 bar. For the other lower floor, after top 5 floor, the pressure by gravity becomes more than 1.5 bar. So we will use the water supply by gravity. You can see the top floor is pressure 1.6 bar, so it is between 1.5 to 2 bar, so we will keep as it is. Then the next floor, the pressure is 1.97 bar by gravity, so we will keep as it is. But when we go the third floor below it, the pressure became 2.3 bar, so we will use the PRV to keep the pressure between 1.5 bar and 2. So we will set the PRV to the minimum 1.5 bar. And for the raised down floor, the pressure will become more and more, so we will use the PRV for all the lower floors. Case 2 is the general method that is used for apartment or other commercial buildings. In this case, we will follow the assumption that ideal water pressure for sanitary fixture is between 40 and 60 psi. As our minimum pressure requirement for the branches is 40 psi, and if we use the rooftop water tank to supply water to the building by gravity, the top floor pressure will be 0 psi. So the top floor that are getting pressure less than 40 psi, we will use separate piping network, and in this piping network we will use a small booster pump having pressure as per the minimum requirement, that is 40 psi. As our pressure range is between 40 to 60 psi, so for the floor that are fed by the booster pump, we will use PRV where we are getting the pressure higher than 60 psi. So you can see for the lower 4 floor we are getting pressure greater than 60 psi. So we will use PRV here for these 4 floors, and we will set this PRV at 40 psi, that is our minimum pressure requirement. You can set your PRV at the maximum limit also, that is 60 psi, but I use 40 psi, that is the minimum requirement for the purpose of saving water. For the lower floor where we are supplying water by gravity, you can see after top 4 floor the pressure became greater than 60, so we will use the PRV, and we will set this PRV also at 40 psi. There is one very important point to remember always. If at any floor you have any special fixture for which the minimum pressure requirement is more than 40 psi, then you need to consider the minimum pressure requirement for that branch as per the actual requirement of that fixture. Let us, for example, we say we have some fixture for which the minimum pressure requirement is 50 psi, then we need to set the pressure for that branch at 50 psi. For example, at top floor we have some special fixture for which the minimum pressure requirement is 50 psi, not the 40 psi. Then we will set the pressure for this branch 50 psi, not the 40 psi. And we will select the booster pump to supply water at 50 psi, not the 40 psi. If this fixture having minimum pressure requirement of 50 psi is available at the floor where we have already pressure between 50 and 60 psi, there is nothing to do. But if this fixture is available at the floor where we have pressure more than 60 psi and we have set our PRV limit up to 40 psi, then we will adjust the pressure from this PRV up to 50 psi. If you are designing a project for hot places like Gulf, where in summer the day temperature will be very high and the water at rooftop water tank will be hot also. So in order to supply the water to the building at normal temperature, first we supply water from rooftop water tank to the heat exchanger or chiller where we cool it to the normal temperature. Then from there we supply this water to the building. I hope this study will help you to understand the domestic water supply system for high-rise building using rooftop water tank. Thank you very much.